All right, now that we've finished talking about carbohydrates, we're going to move on and talk about proteins. Now, if there's one thing I've learned from years and years and years of working with athletes, it's that proteins are just as misunderstood as carbohydrates. Now, whenever we think of proteins, people often think of Arnie Schwarzenegger and protein powders, and we often think of building muscle and bodybuilding. Don't get me wrong, protein is really important for muscle, but it's important for so many other things other than that. Protein is not just really important for muscle, it's important for hormones, your enzymes, building your immune system, building many other cells, your bone, your hairs, your nails, and many other things throughout your body. Because of protein's extreme importance throughout the body, it's important you understand how to practically reach your protein needs through foods. In order to do that though, first we have to look at exactly what protein is. And to do that, we need to have a conversation about amino acids. Amino acids are to proteins what sugars are to carbohydrates. They are the building blocks, and there's 20 amino acids in total. Now, of that 20 amino acids, there are 11 that we call non-essential amino acids. All that means is that our body is very capable of making all of those amino acids with everything we already have in our body. The 9 other amino acids are what we call essential, meaning we have to get them through foods in our diet. This idea of essential and non-essential often creates this idea of important and non-important proteins, and that's not the case. All amino acids are important and all of them are used for different functions throughout the body. It's just a really important point that you have to really get in your head is that the non-essential ones our body can make and the essential we have to get from foods in our diet. So to help understand this whole concept of essential versus non-essential, it's helpful to look at what the high protein foods are. High protein foods include things like lean meats, poultry, seafood, fish, eggs, dairy products, and also things like chickpeas, lentils, and many beans. So the real world importance of the amino acid profile of foods becomes evident when you look at those profiles of the different protein foods I just mentioned. So when you're looking at things like lean poultry, seafood, fish, eggs, and dairy products, you'll see that those foods contain all 9 of the essential amino acids. Whereas when you look at plant-based foods like chickpeas, lentils, or legumes, you'll find that there isn't a complete profile of the essential amino acids, and you're only getting a few of those essential amino acids with each one of those sources. This is important when we talk about, say, plant-based diets or people who follow a more vegetarian eating style. If they're excluding things like animal-based products or dairy from their diet, they're excluding the main sources that contain all of these essential amino acids, and they're consuming protein sources that contain predominantly the non-essential amino acids. This isn't necessarily a bad thing though. What this does mean is that when they're eating predominantly the protein sources with the non-essentials, they'll have to eat either a combination or a variety of those plant-based sources to ensure that they are in fact getting all 9 essential amino acids. Now, this doesn't mean that a plant-based diet is any inferior to an animal-based one or a meat-based diet. All it means is that you got to be a bit more creative and a bit more technical when you're trying to get all of your complete amino acids. So what that means is that you'll probably have to be eating a good variety of things like chickpeas, lentils, beans, quinoa, tofu, lots of different plant-based sources to ensure that every day you are getting adequate essential amino acids in your diet. Now, just eating all of your proteins is just half the battle. The other half is how well they digest in your body. Now, there's this thing called the digestible indispensable amino acid score. That's a real mouthful. But what it really means, it just describes how well each of these amino acids are actually digested and absorbed once we get them in our body. The interesting thing about this scoring system is that it clearly shows that animal and dairy-based amino acids digest far better than plant-based amino acids in the human body. This isn't throwing any shade on plant-based or vegetarian styles of eating. Again, it's just re-emphasizing the point that our body is much better at absorbing these more animal and dairy-based products. And all you have to do if you do follow these types of diet is just put a bit more effort in, making sure you're getting good variety and probably eating more overall protein sources to hit your daily protein needs to make sure you're getting all those essential amino acids. I guess now you're wondering and thinking, well, what happens if you don't get enough of these essential amino acids? Because protein has such widespread function throughout the body, you see lots of changes. You see decreased in bone health, you see decreases in fertility, you see decreases in immunity, decreases in red blood cell function, losses of muscle mass. You see lots of negative effects throughout the body. The thing is though, is that having a protein deficiency is quite rare, even if you are a vegetarian athlete or someone following a plant-based diet. Now, a question that I always get when we talk about protein is supplements. And the first question we always get is about branched chain amino acid or amino acid supplements. Now, if you're having enough protein in your diet and you're meeting all of your essential amino acid needs through food, there is absolutely no reason why you need a supplement. But a supplement is exactly that. It's something to supplement your diet. If you find yourself that you cannot get a meal in at lunch or dinner because you're working or you're running around or you're training, for whatever reason, that is when something like a whey protein isolate or a whey protein concentrate protein supplement can be really useful. These animal-based protein supplements will give you all of your essential amino acids. It's important to keep in mind that a lot of plant-based protein supplements will not give you all of the essential amino acids unless they've been enriched or fortified. And it's also important to keep in mind that supplements like branched chain amino acids are only giving you 3 of the amino acids. So it's important to keep in mind, food comes first. If you're getting all of your protein throughout your diet, there's probably no need to supplement. If you need to put in a supplement because you simply can't eat the food, completely okay. If you're looking at supplementing with individual amino acids, it's probably going to be a waste of time, especially if you've got good protein sources in your diet and you're already taking a protein supplement. So now that we've discussed what protein foods are and what they're made of, we have to talk about what happens to protein foods once we eat them and they get in the body. So once we eat protein-rich food, we put it in our mouth, it goes down our esophagus, into our stomach. Once it's in our stomach will release something called hydrochloric acid, which is a really strong acidic acid, which will start breaking down those polypeptides into smaller units. Once those smaller units are small enough, they'll move into our small intestine, where our pancreas will send in some more support to help break them down even further into our single amino acids. So once these amino acids are broken down in our small intestine, they'll move into the blood, where just like carbohydrates, a number of things can happen. The first thing that will happen is that they get sent to the liver and they'll be used for protein synthesis. This is where these amino acids will get reconfigured into different protein structures to meet the needs of the body at that time. For example, if you go to the gym and you start lifting a lot and you're breaking down your muscle tissue and you're putting in good amounts of protein around that time, your body will break down that protein, send it to the liver, and the liver will send it to the muscle to build more muscle proteins. However, if there isn't an immediate need for protein synthesis throughout the body, the second option for these amino acids is that they'll be sent to different parts of the body to engage in either carbohydrate or fat metabolism for energy. It is important to note though, that energy produced from these amino acids only makes up about 15% of the total energy production of the body, which is relatively small in terms of the energy produced by the macronutrients. So the last thing that can happen to amino acids in the body is this process called transamination. Now, transamination is a pretty complicated process that just describes how our body takes amino acids and adds it to urine to get urinated out by our body and put in the toilet. Now, during that process, our body takes that amino acid, sends it to our liver, and then through some chemical pathways, it'll turn into ammonium. Now, if you're an avid gardener, you've probably heard of ammonium and you've put it on your plants. In low doses, it's really good. It'll act as a fertilizer and help promote the growth of those plants. But if you put too much ammonium in your garden, it'll kill everything. That's because ammonium in high doses is really toxic. And this is why I'm describing this process of transamination, because it was once thought that if you ate too much protein in your diet and your body had to continually do this transamination process, that your liver would have to deal with too much ammonium and it would become toxic to your liver.